ever download what seemed like a totally harmless file,
Mm.
only to realize, oh, it can see like everything on my computer. Ugh, talk about a tech nightmare.
Yeah.
Today's deep dive is all about E.
Okay.
It's a programming language that wants to like make those security nightmares a thing of the past.
And it's not just about making things feel safer.
Mm.
E is built from the ground up with security as its core principle.
Okay, so we're not talking about just putting a Band-Aid on the problem. We're talking about actually like rewriting the rules of the game.
Exactly.
Color me intrigued. We've got excerpts from the erights.org wiki to kind of guide us.
Right.
And the first thing that jumps out is this whole idea of object capabilities.
Yeah.
Sounds kind of complicated, honestly.
It's actually quite elegant when you really get down to it.
Uh-huh.
Imagine you have a bunch of keys, right?
Mhm.
On a keychain.
Yeah.
Each key grants you access to a specific room or building.
Okay.
Object capabilities work similarly in E. Each part of your program only gets access to what it absolutely needs to function, and that's it.
Hold on. Are you telling me that even if like someone hacked into my chat app, they couldn't touch the rest of my computer?
That's the idea.
That's huge.
Exactly. Think about how most software works now. It often asks for way more permissions than it actually needs.
Right.
E flips the script. With E, even if one part of a system is compromised, the damage is contained. It's like those security doors you see in spy movies. Only one section opens at a time.
Okay, yeah, that makes sense. But doesn't all this security stuff make programming in E more complex? I mean, I can barely keep track of my digital keys, let alone ones and zeros.
Surprisingly, it's often the opposite. E actually simplifies things in many ways. The article even mentions that a more secure program is simply one that follows OO principles of modularization more closely. It's like organizing your tools in a workshop. Everything has its place, and you're less likely to accidentally use a screwdriver when you need a hammer.
So good security equals good organization. That's a concept I can definitely get behind. But E isn't just about security, right? It's designed for this whole future of distributed computing, as they call it.
Right,
What does
right.
that even mean?
Think about how we use the internet. Now we're constantly interacting with, systems spread across the globe.
Yeah.
Distributed computing means programs aren't limited to just your computer.
Yeah.
They can tap into the power of a whole network of machines.
So like a whole team of computers all working together.
Exactly. But coordinating that team, well, that can be tricky. You know how frustrating it is when your computer just freezes up because one program is stuck?
The worst.
E has a pretty brilliant way of avoiding that. It uses what's called an eventual send.
Eventual send. Does that mean I have to wait forever for my computer to do anything?
Not at all. It's about working smartly, not slowly. Imagine telling one of your team members to do a task, but you don't stand there like awkwardly waiting for them to finish, right?
Yeah, makes sense.
You trust they'll get it done, and you move on to other things in the meantime. That's what's so powerful about eventual sends. They free your program to keep running smoothly, even if some tasks take a while to complete.
Okay, that's starting to make sense. So instead of my program getting bogged down waiting for something to happen, it can just fire off instructions and keep humming along.
Precisely. This asynchronous approach is especially crucial in a world of distributed systems, where communication lags and unexpected delays are, well, they're just the norm. E lets you write code that's both efficient and incredibly robust, even when dealing with the unpredictability of the internet.
This is blowing my mind. So E is like the ultimate multitasker, never getting bogged down by waiting. But if we're not waiting, how do we get those results back? It's not like I can just hit pause on the real world while my program is out there doing its thing.
That's where promises come in.
So these promises, are we talking like digital pinky swears here, or is this something a little more, concrete?
Think of it like this. You order something online, and you get a confirmation email, right?
Right.
That's your promise. You don't have the package in your hands yet, but you know it's on its way. You can even track its progress, see where it is.
Okay.
In E, a promise is a guarantee that you'll get a result from those eventual sends we talked about, even if it takes a little time to get there.
Okay, I think I'm starting to get it. So my program sends out these instructions. It gets back these promises, as you call them. And then it can just kind of, keep on trucking. No more digital traffic jams.
Scott,
Okay.
it can feel a bit like you're juggling chainsaws at first, not gonna lie, but E provides ways to regain control. You can set up specific instructions for what to do once a promise is fulfilled, so you're not just blindly waiting around.
This is all starting to sound incredibly powerful, but also very theoretical. Does E actually deliver on these promises, no pun intended, in the real world?
It absolutely does. In fact, this eWrites.org wiki we're looking at gives a fantastic example, MinChat.
Okay.
It's a simple chat application built entirely with E.
So like a super secure instant messenger, is that what we're talking about?
Yes.
Tell me more.
Exactly. And what's really cool is that the article actually walks us through a whole security audit they did on MinChat.
Oh,
They basically tried to hack it to see if E's security really held up.
okay. Now we're getting to the good stuff. So, did it pass the test?
With flying colors. Remember those object capabilities we were talking about earlier?
Yeah.
Because MinChat is built with E, it only has access to the specific resources it needs to function, like, network communication for sending messages, display for showing them on your screen.
Right.
But that's it. Even if someone managed to completely hijack the MinChat app itself.
They still wouldn't be able to get to, like, my private files or install malware on my computer.
He nailed it. It's like having a security guard who only lets certain people into certain rooms. Even if someone sneaks past the guard, they're still limited in what they can actually access.
Wow, that's incredibly reassuring. It's amazing to think that this level of security is even possible, honestly. But what about other types of attacks? Like, what if someone, I don't know, tried to impersonate my friend in the chat? Could E protect against that?
E has you covered there, too. Remember how each object in E has that unique identifier, like a digital fingerprint?
Yeah.
It's nearly impossible to fake those. Plus, E uses this clever pet name system. So even if an attacker tried to disguise themselves as your friend, you would still see their true, unfakeable ID right there in the chat.
So it's like a built-in lie detector for my computer.
That's amazing. Okay, I'm starting to see how E could really change the way we think about online security. But we've been focusing a lot on just one example here, MinChat. How does E actually hold up in, more complex distributed systems like in the real world?
That's where E really shines. Because it's designed for distributed computing from the ground up, those eventual sends we were talking about earlier, they're not just efficient, they're inherently secure as well. Okay, now you're going to have to explain it to me like I'm not a computer scientist. How can sending a message be inherently secure? What does that even mean?
Imagine sending a postcard versus sending a letter in a tamper-proof envelope.
Okay, yeah.
Traditional programming, it often sends data, more like a postcard. It's easy to intercept and read if someone's listening in. But with E, every message is like that secure envelope, encrypted and authenticated automatically.
So you're telling me I don't need to be a cryptography expert to send secure messages with E. It just, handles it all for me.
Precisely. You can focus on writing your code, the logic of your program, and E ensures that it's executed securely, no matter where different parts of your program are actually running, whether it's on your machine or a server across the world. This combination of secure communication and fine-grained access control, that's what makes E so powerful.
It's like having this whole team of, expert security guards, cryptographers, and network engineers all working behind the scenes, making sure your code is always protected. That's a serious weight off any programmer's shoulders, I have to imagine.
Exactly.
Yeah.
And this approach, it opens up all these exciting possibilities for building systems that are both robust and flexible. You can create these incredibly complex, interconnected applications without compromising security or performance.
It all sounds almost too good to be true. Are there any downsides to programming in E? I have to imagine there's got to be some kind of trade-off, right?
Yeah.
So it sounds like E has, a lot going for it, honestly.
It does.
But are there any trade-offs, anything we're not seeing here? Is it one of those too good to be true situations?
Well, no system is perfect. As the article mentions, working with those eventual sends and promises, it can feel a little different at first.
Okay.
It takes some getting used to not always being in direct control of exactly when things happen.
Right, like letting go of the reins a little bit, trusting the system.
Yeah, exactly.
But I thought you said E provides ways to regain control, when you need to.
Absolutely.
Yeah.
E has some pretty cool features for that. There's this thing called when catch, which basically lets you specify what to do once a promise is fulfilled. It's like leaving a note, on that secure envelope we talked about, saying, hey, once this gets there, here's what I want you to do with it.
Okay. So you still have control. It's just more about, setting things up in advance, and letting E handle the timing of everything.
You got it. Think of it like setting up dominoes.
Okay.
You arrange them all carefully, and then one push sets off that whole chain reaction.
I like it.
And for, more complex scenarios, E's got even more tools like promise pipelining and summoners, which sound way more intimidating than they actually are in practice.
Okay, good to know. Good to know. It seems like more than anything, it's just a different way of thinking about programming.
It really is.
And the benefits we've talked about, better security, increased efficiency, easier distributed computing. I mean, those sound like they're worth the learning curve, honestly.
Absolutely. And that's not even everything E has to offer. The article touches on some other fascinating aspects, like quasi-literals, for example. These are like built-in shortcuts for common tasks that you might need to do.
Shortcuts are always good. Tell me more.
Imagine you're, I don't know, writing an email, right?
Yeah.
And instead of typing out your entire address every single time, you just hit a button and it fills it in automatically.
Right.
Quasi-literals are kind of similar. And they let you embed these complex operations right into your code, making it more concise and easier to read, which is always nice.
Elegant and efficient. I like the sound of that. What else is there?
Well, there are also e-makers. Think of them like pre-built modules of code, but with that same strong security we've been talking about baked right in.
Ah, so like those code libraries you can find online, but with ease, security guarantees.
Exactly. E-makers are designed to be shared and reused without compromising on security, which is huge. They operate within a very limited scope, so even if something goes wrong with an e-maker, it can't really wreak havoc on your entire system, which is a relief.
It's like those safety boxes you see in like labs.
Yeah.
They're there to contain any explosions or, hazardous reactions. Smart. So we've covered a lot of ground here. What's the key takeaway for our listeners at home? Why should anyone care about E?
Because E represents a fundamental shift in how we build software. It's about moving beyond that old patch and pray approach to security,
Yeah.
and creating a future where security is the default, not an afterthought.
It's like the difference between building a house with flimsy locks and just hoping for the best versus actually building a fortress from the ground up.
Precisely. And this shift, it has implications far beyond just, the technical world. Imagine a world where the apps on your phone, the systems that control our, critical infrastructure, imagine if they were all built with E's security principles in mind from the start.
A world where you don't have to worry about every app overstepping its boundaries or hackers holding your data hostage. That sounds pretty utopian, honestly.
It's a future worth striving for. And E, well, it might just be the tool that gets us there. It empowers developers to build software that is not just powerful, but also trustworthy, which is huge in this day and age.
That's a powerful thought to end on. Thanks for taking us on this deep dive into E. It's clear this language has the potential to really change the world of software as we know it.
My pleasure. It's always exciting to explore these, emerging technologies and see what the future holds.